You want me to like do Jonah's voice?
So adding and subtracting, pretty straightforward. At the end of the class today, we're going to combine everything from yesterday and today. So if we'll put phones and games away, please. Okay. So adding and subtracting radicals. So you can't just say like yesterday, oh, I have the same index. I can multiply them inside. You can't say I can add them inside. All right, it's not how it works. So if you look at their example and say, well, if I take the square root of 4 plus the square root of 9, that means the square root of 13. No, that's not the same case. Because if you take the square root of 4, that's 2, and the square root of 9 is 3. Square root of 13 is definitely not 5. Okay? So when adding and subtracting radicals, we do not just add or subtract the numbers inside the radical like we did yesterday. Okay? That's a little bit different from what we were doing yesterday. Okay? So when can we combine radicals? We can combine them if two things are the same. If the radicands are the same, remember that's what's underneath the radical. And if the index is the same. Okay? And that's on the next slide here. To add and subtract radicals, it's almost like combining like terms. They have to have the same radicand and the same index. Okay? Same radicand and same index. There's some examples of the ones you would combine, the like terms, and ones you would not combine. Okay, so they have to have the same radicand and the same index. All right, so what does that look like? So let's look at the first example. They have the same index, which is 2. They have the same radicand, which is 5. So as simple as it looks, I just add the two numbers in front. And that's it. Okay. Treat the radical as almost like a variable, and you're just going to combine your 6 and your 3. Just like if I had 6x plus 3x. I don't do anything to the x. It just stays x, just like it's just going to stay the square root of 5. Okay? Go ahead and try the next two. Okay, so the second one, I have the same index and I have the same radicand. So 5 minus 4 just gets me 1. So I just get the square root of 7. But the next one, I have different radicands. I have a 2 and I have a 3. Pay attention to what the directions are asking you to write. If the directions say, if it's already simplified, write already simplified. Or if it says, if it cannot be simplified, write cannot be simplified. Just whatever they prefer you to write. Or you can actually just rewrite the question again, okay? Don't leave it blank. Just because you're like, well, I can't do anything to that, so I'm just going to leave it blank, all right? So you can either rewrite 10 root 2 plus 10 root 3, but if they tell you an option of it's already simplified, then you'll write already simplified. So it just depends on what the directions are asking you to put, okay? So you'll just kind of go along what they ask. All right? Let's try some more. Try these 4. Okay, so the first one, pretty straightforward. You just get 2 square root of 3. The next one, there's a little 3 there. I don't know if you can see it very well. That's the cubed root. So this is already simplified. Okay. Over here, I can only combine these two because they're both the square root of 3. So if I have 5 root 2 plus 10 square root of 3, if you wrote it 10 square root of 3 plus 5 square root of 2, that's fine. Not going to be picky about that. And the last one, I have 7 minus 5, so I just end up with 2 square root of 2. Okay. So these are all nice and pretty. Of course, it's not always going to stay nice and pretty. It's not how things work in math. The way these get harder is you have to simplify before. So stuff we've been doing the past couple of days, well, day, it's only Tuesday. Feels like it's been days. We might have to simplify those first to see if we can combine them, okay? So again, what we've been doing, not too much is different. Variables are the same way. We don't need to do one of those. If they all match inside there, then you can combine them. So let's try. I do want to look at this one real quick. You have to be careful with variables in general, okay? And what I mean by that is, yes, we have the same index and radicand, but if you have a variable on the outside of the radical, that also has to be the same as like it was back when you were in Algebra 1, okay? So you can't just combine these right here if one of them didn't have an x, okay? So it's the same rules that have applied in Algebra 1 with these problems here. So yes, I would be able to combine all these, but if let's say this 2 didn't have the x, this I can't combine with these, even though it had the same radicand and same index. Okay, so just kind of be on the lookout for that. So then I'd have 6 plus 5, which is 11 minus 2. So I'd get 9x square root of 3. Okay, just kind of keep a lookout for those in case the variables are on the outside. Those have to be the same as well. Okay, any questions on that? Okay. So, how can these take a step up? Well, I look at these problems and I say, well, 12 and 3, they aren't the same. But could they be? Possibly. So go ahead and reduce any radicals that can be reduced, and then see if you can add or subtract. So if I look at the square root of 12, I know some of y'all have moved on to the second one. If I look at the square root of 12, we know that my perfect square is 4, so that just becomes 2 root 3. Now that's something I can combine. So 2 minus 1, I just end up with the square root of 3. Okay. So in most cases, you have to look and see, hey, can I completely simplify all this stuff? If I can, great. Not, then it's already simplified. So if you haven't done the second one, go ahead and knock out the second one. I know some of us like to go back to doing perfect squares. Great, go for it. Some of us are like, hey, that ladder thing worked for me. Go for it. I just did both of them for y'all so you could see them. So if I get 2 root 2 plus 3 root 2, and then I'm going to get minus 10 root 6, I know I can't combine it with that last one, but I can combine these two together. So 5 square root of 2 minus 10 square root of 6. Okay. Any questions on those so far? Again, we're simplifying like we were yesterday. And then if we can add some things or subtract some things together, great. That's the added bonus, different from yesterday. Okay. All right. What about variables? Same thing. See if you can simplify it first, and then if it can be combined, go ahead and combine it. We try both of those. Remember to look out for both the index, the radicand, and if there are any variables in front. Okay, so if I have 3 x's on the inside of a radical, I know that I have 2 that are I can pair together and 1 left over. So if I take out an x, that becomes x squared. Same thing here, I can't do anything with all of that. So because I have the same index and radicand, and these are the same, I can combine it. So I get 2x squared square root of x. Okay. Same thing over here. I can't change the first one. But if I have 3 y's, I've got a pair that can come out and one that stays on the inside. So since I have a y and a square root of y, I have negative 2y square root of y. That is all the same, okay? So just be careful with the variables that you're making sure everything matches. Okay, should we amp it up a little bit? I know some of y'all were doing this, but I think you meant this. It's okay, I know. You do. You do. The answer is always yes, right? Okay, go ahead and try this one. And this is not the one I am saying that we're amping it up. The next one is. We're dipping our toes in the water right now. Okay, how many of y'all thinks it's A? B? C? B? Unsure? Not raising your hand? There's a couple of y'all. Okay, so B, hold on, let me start up here. A is if you said, hey, let's add those together, which that doesn't make any sense because 2 and 4 don't really give me 3. So I probably would have made that 6 square root of 30 to kind of throw you off there. B is if you forgot this 4, okay? Because 27, if we reduce that, we get 3 root 3. So if you notice, if you forgot the 4, you would get 5 square root of 3. So don't forget the 4, all right? But since it is there, that's 12 plus 2. So yes, C is our correct answer, okay? All right. So the next one, 100% doable, but it's long, okay? Go for it. Take it one radical at a time. Reduce each one step at a time, and then see what can be combined. All right. Did anyone get A? B? C? E? So a third of y'all answered.
I just finished.
You do what?
I just finished.
I
Okay.
forgot there were answers on the board.
I got B.
Okay.
So I don't want to
All right. So one step at a time. We know 8 is 2 root 2. If I have 3 x's, I have one pair of x's that can come out and one that has to stay in. Y to the 4th, I have 2 pairs. Okay. Then from there, I break down 128. I have 1 pair, 2 pair, 3 pairs. That gets me 8. 2 times 2 times 2. And then I have a square root of 2 still left. 3 x's again. 1 pair with 1 left over. Okay. Now we do 98. I'm running out of room. Okay, let's start that over. Divide that by 2, we get 49. That's a 2 in there. You can't see it, but it's there. And then we know we get 7 and 7. So 7 comes out. Same thing with our x's that we did on the other ones. And a 2 has to stay in. So does an x. Remove this out of the way. And our last one, 12, we know that's going to reduce to 2 root 3. We still have an x that came out. We still have our y squared, but then we have 3x inside here. So we are going to be able to find everything except for that last term. So 2 plus 8 gets me 10, minus 7, which is 3. That is why B is our answer. Okay. We cannot combine it with that last one because it has a 3 in the radical instead of 2. Okay? Any questions on that? All right, let's go ahead and take a quick break. We're going to do some more multiplying and dividing. All right, let's go ahead and come back to it. Knock it out. Start on our homework. So the reason why we went through adding and subtracting a little bit before we go into more multiplying and dividing is because you needed to know when you can start combining things. So if we have a monomial outside of a binomial, then we know we're just going to do the distributive property. Okay, so same rules, everything still applies. So if I multiply here, I get 3 square root of 18. And if I multiply here, I get plus 3 square root of 12. So can either one of these radicals be reduced any further? Yeah. So go ahead and reduce those, and then if you can combine it, great. If not, then you have it down to its simplest radical form. Remember, you can only multiply the numbers on the outside together and multiply the numbers on the inside together, but not inside to outside or outside to inside. Okay, so if I break down 18, I get 3 root 2, which makes this 9 square root of 2. And 12 reduces to 2 root 3, so that becomes 6 square root of 3. And we have different radicands, so we cannot combine those. Okay, so even though you can't combine them, I want my answers in simplest radical form, so make sure that they are completely simplified. Okay, go ahead and try number 12. Okay, if I multiply through, I get -4 times the square root of 9. I'll deal with that in a second. Then -4 times -5 gets me a positive 20 with the square root of 6. But I end up with square root of 9, which is 3, times -4 is -12, plus 20 square root of 6. Tempting, but do not add the -12 and the 20. -12 does not have a square root of 6 with it, so you cannot combine those. 6 I can't reduce. I can divide it by 2. I get 3, but I won't get any pairs out of it. So that is my most simplified radical form there. Okay. So if I'm having you do a binomial and a monomial, I'm also going to have you do a binomial times a binomial. In other words, you're going to either double distribute or FOIL, whatever you call it. Okay? So go ahead and try both 23 and 24. Make sure you're doing the 23 and 24. Okay, let's look at the first one. So I get square root of 4. I get 2 square root of 10. I get another square root of 10. And I get 2 square root of 25. Okay, so then from there, I know that my 4 is going to get me 2. And then over here, I get 2 times 5, which will get me 10. Okay? So then I have my 10 and my 2, so I get 12. And then I can combine these, and that gets me 3 square root of 10. Okay? So now we're combining everything we've learned pretty much with radicals all in one problem, okay? The next one, I get 5 square root of 25 minus the square root of 10 plus 5 square root of 10 minus the square root of 4. So my 5 times 5 will get me 25 over here. Minus the 2 there will get me 23. And then here I get 4 square root of 10. Okay. So with all of these lessons, they keep building onto what you could possibly do next, okay? So what I want you to do, let me see if I've got one up here. If not, I can make one real quick. Nope, I got one. Good news. Let's do this. Okay, try this one. So there's a reason why I picked this problem. You get just a normal number, I hope. Okay. So the reason why I picked this particular problem, does anyone remember what these are called? Not different. Conjugates, okay? Remember, if I have A plus the square root of B, then A minus the square root of B is its conjugate, okay? So there's a reason why we did those with complex numbers was because it got the I out of the denominator. Well, we're going to use that same idea to get the radical out of the denominator, okay? So if I multiply these together, I get 25 minus 5 square root of 5 plus the square root of 5, or 5 square root of 5. That's the whole purpose right there. That middle term will cancel out. And then minus square root of 25, and we'll get to that in a second. So this cancels, and I get 25 minus 5, which gets me my 20 as an answer. So we use the conjugate to make radicals disappear. We use the conjugate to make i's disappear. So basically the conjugate just gets rid of all the ugly stuff for us, okay? And that's why we use it. So what are we going to use it for? We've done adding and subtracting and multiplying. You're still dividing, okay? So these are just a step up from what we were doing the other day. We had just one radical in the denominator, but a monomial down there. Now we have a binomial. Well, if I want the radicals to disappear, all I have to do is do the conjugate, okay? So, looking at the first one, I'm going to simply just multiply by the square root of 5 plus the square root of 2. Okay, the only sign that changes is the one in the middle of the 2. So now, The numerator is what we did 2 slides ago, and the denominator is what we did on the last page. So go ahead and multiply that out. So now we're really combining everything we've learned so far. So we multiply by the conjugate, which means just the sign in the middle changes because we want the middle term to disappear.
The square root switch or
Like that. I want it just like that. Because that last slide, how I showed you 8 plus the square root of b. That's how I want you to write your answers. Make sure you're simplifying it all the way down to the end. If you end up with a radical in the denominator, you either didn't multiply by the conjugate or you messed up somewhere. Okay, so again, the whole purpose of multiplying by the conjugate is that radicals disappear. So in this particular case, my middle term disappears. This gets me 5. This gets me 2. Okay, so up here, square root of 4 is 2, so I get 3 times 2, which will get me 6. So if I want to write this in standard form, I'm going to put 6 plus 3 square root of 10. And my denominator, I have 5 minus 2, which gets me 3. And yes, the Dorito chip still lives here. Still happening. Okay? So then they are all divisible by 3. So let's divide them by 3. So I should have gotten 2 plus the square root of 10. If I can reduce the square root of 10, the expectation is that you do that, but you can't. So that is your final answer there. Questions on that? I did a lot in that second step, so if you need me to write that out, let me know. Kind of wrote some stuff off to the side, didn't really show my work on an actual progression of it. Okay. Use that and try the next one. All the way through. And then we just have one more after this one. This problem to me is just so ugly because it's like you want it to go further, but it doesn't, okay? Especially when it's like, well, I can divide those numbers, but they don't give you pairs or a perfect square doesn't go into them. So if I multiply by the square root of 3 plus the square root of 5, okay, I get 2 square root of 21 plus 2 square root of 35. All over, I get the square root of 9 plus the square root of 15 minus the square root of 15 minus the square root of 25. So again, my whole goal here is the middle term disappears. And this gets me 3. This gets me 5. So 2 square root of 21 plus 2 square root of 35 all over 3 minus 5, which gets me a negative 2. Now, Dorito chip, we can see that they are all divisible by 2. But I also don't want a negative just floating in the denominator for no reason. So I'm actually going to divide everything by negative 2. So my answer should just be negative square root of 21 minus the square root of 35. And again, like I say, you really want 21 to reduce and 35 to reduce, but 21 you get 3 and 7, and 35 you get 7 and 5. So it doesn't reduce like you want it to. Okay? A lot of pretty math up there. Any questions about those? Yeah.
So, what's this used for, like, long term?
What is this used for?
Like, what are they gonna use this for in the future? Not like, what are we gonna use this for? I mean, like, in class.
Like in class?
Yeah, where is this gonna go?
A lot of these radicals will pop up again in pre-cal. we're also going to use a lot of these radicals too in logarithms. So trig and logarithms and stuff like that too. We'll be using a lot of it for. What you're technically doing is you're doing what they call rationalizing the denominator. In other words, you are simplifying the fraction because you cannot have a radical in the denominator. So you're simplifying that just as much as, let me take it down to an elementary level. You would never write your answer as 5 minus 3. It's not complete. It's not simplified. You would write 2. Same thing here. This is not complete. This is not simplified until the radicals are out of the denominator. Okay? As promised, one more problem. And as promised, I'm going to up the game a little bit more. We're going to do a binomial over a binomial. Our main goal is that the denominator doesn't have a radical in it. So if that's the case, I'm still only interested in the conjugate of the denominator. Okay? Not the conjugate of the numerator. I want the conjugate of the denominator. Try this one out, and this will be our last one. All right, so if I multiply by the conjugate, okay, I get 2 plus the square root of 8 minus the square root of 64, which technically I could put 8 already. I'm jumping a step here. And then 4 plus 2 square root of 8 minus 2 square root of 8, and then minus 8 again. I went ahead instead of the square root of 8, or I didn't write the square root of 64, I just went ahead and wrote 8. Okay. Middle cancels out, which is what I want. I have 2 minus 8, which gets me negative 6. And then I have 1 minus 2, which gets me a negative 1. All over 4 minus 8, so that's a negative 4. And they are not all divisible by anything yet, except for the 8 I can reduce. So negative 6 minus 2 root 2, all over negative 4. Now they're all divisible by 2, negative 2 for that matter. So I get 3 plus the square root of 2 all over 2. Or you can write it as 3/2 plus root 2 over 2. Either way, doesn't matter. Okay? Any questions on that one? That one's the big one. That one has everything in it. Yeah.
Why can't you cancel out the negative 8? Who's on the top and the bottom?
It'd have to be in every single piece. Good question. Any other questions? All right, so you're going to do 6.3 today. So go ahead and get started on that. And tomorrow we'll move on to 6.4.